René Descartes and many other philosophers propose deductive reasoning as a way to achieving scientific knowledge, because when you use deductive logic, you can reach conclusions that necessarily follow from the premises. So you can achieve certain universal knowledge. So let's see how deductive logic works. So logic is about arguments. And arguments are composed of one conclusion, that's what we are arguing for, and premises, which are the reasons we give as justification for the conclusion. Now, Aristotle created syllogisms, which are arguments that contain two premises and one conclusion. Now, there can be arguments with many more premises, but always one conclusion. Syllogisms have two premises. Arguments are evaluated in terms of two criteria, their validity and their well-groundedness. And if an argument is both valid and well-grounded, the argument is sound. An argument is valid if and only if, assuming the truth of the premises for the sake of argument, the conclusion follows from them. It is very important that the premises don't need to be true. The premises are assumed to be true for the sake of argument. So, if we assume that the premises are true, then an argument is valid if the conclusion follows from them. And we are going to see many examples about that. So, let's see this argument. Two premises and one conclusion. The two premises are all humans are mammals, and this organism is a human. Conclusion, this organism is a mammal. So we need to assume that the first two premises are true. We don't test whether they are true or not. We just, for validity, we only assume they are true. Now, does the conclusion follow from the two premises if the two premises are true? Well, the way we do that, and there are many ways of doing that. One is to use some logic tables, but I prefer to use something that was shown, that's the way humans, without knowledge of logic, solve these logic problems, and that's using mental models. So I'm going to do it in the way I solve these problems. So here we've got the first premise is all humans are mammals. So we've got in this scheme some humans, and it says that all humans are mammals. So this represents all humans. Let's say these are all the humans. And now we have to say that all humans are mammals. So note that the M refers to mammals, and for each of the humans there is an M, because all the humans must be mammals according to the first premise. Now there are more M's because it doesn't say that all mammals are human. It says that all humans are mammals. So there may be, perhaps not, but there might be some mammals that are not humans. So that's why I represent here, I put more M's than humans. Okay, so second premise. This organism is a human, so we have some organism here and we claim it's a human. So in order to do that, we put the O for organism in one of the humans. And so it will be the same in each of the humans. We put the O in any of these humans, and they will always be in a column that aligns with a mammal. So we can conclude that this organism is a mammal. So this is a valid argument. As I said, there are more formal ways of doing that, but this is the way humans tend to use to solve these problems when they don't have knowledge of logic. Okay, so this is a valid argument. Now, let's see this argument. And this argument has the same structure as the previous one, but I change monkeys instead of mammals. So all humans are monkeys. We have to assume this is true, even though it's not. But for evaluating the validity of the argument, we have to assume this is true. And we have to assume that here I have an organism that is a human. And the conclusion is the organism is a monkey. Is this a valid argument? So does the conclusion follow from the premises if the premises are true? It does, because it has exactly the same structure as the previous problem, and therefore it should be valid. So all humans are monkeys. So the M now stands for monkey and not for mammal. And this organism is a human. So basically, same structure. This organism is a monkey. It's a valid argument. Now, you may think, well, why do we use valid arguments? This is a bit nonsense. Well, we need to evaluate something else, which is the well-groundedness of arguments. So an argument is well-grounded if and only if all of its premises are true. So if the two premises are true, the argument is well-grounded. So all humans are mammals. It's true. And this organism is a human. Well, let's say I have here someone beside me who is a human. I'm referring to that person or to that organism. So true. Well, that's it. Well-grounded argument. So it's a well-grounded argument, and we saw before that it's a valid argument. So if it is well-grounded and valid, it's a sound argument. And that's what science tries to do, to have well-grounded and valid arguments, not just valid ones. So that's sound. Let's see the well-groundedness of the second argument, which was all humans are monkeys. Well, that's not true. We know that they are not. So that's false. That's it. Not well-grounded, because both premises have to be true in order for the argument to be well-grounded. Now, it is a valid argument. We saw that before, but we need both validity and well-groundedness in order for the argument to be sound. So it's a not sound argument. Let's see in a more abstract way. So instead of giving some content, we use letters in these arguments. So all A's are B's, this C is A, and this C is B. That has the same structure of the problems we've seen before. This is called modus ponens, and a modus ponens is a valid argument. Now, modus tollens is also a valid argument, but it's quite different than the previous one. All A's are B's, that's the same as before, and now we negate the consequent. So the consequent here is B. The antecedent, sometimes you'll find these terms, antecedent is A in this argument, because it's the first element of the first premise, and the consequent B is the second part of the first premise. Now, we are negating the consequent, and that's and we can reach a valid conclusion if we do that. So this C is not B. Then we can say that this C is not A. That's a valid argument. And I show you that. So let's see this this argument, the modus tollens with content. All humans are mammals. This organism is not a mammal. Then we can conclude validly that this organism is not human. So first we establish the well-groundedness. Is this true? Yes, it's true. All humans are mammals. This organism is a mammal. Let's say I have here a chicken, and well, so we say this premise is true. Then this organism is not human. It follows from. So no, we establish the well-groundedness by establishing that the two premises are true. So now we have to establish the validity of the argument. Okay, so let's use the method I used before, which is using mental models. So all humans are mammals, same as before. This organism is not a mammal. So this organism has to be outside. It cannot be aligned with the M's. So it has to be there. And so if you cannot align this O with any of the M's, it means that it will not be aligned with humans either. So we can establish that this organism is not human. So this modus tollens is a valid argument. Okay, in this case it's also well grounded, so it's a sound argument. Now, this is the problem. So until now it worked very well, but deductive reasoning. So why people oppose to deductive reasoning and they propose inductive reasoning? Inductive reasoning doesn't allow to provide certain conclusions, but deductive reasoning does. Well, the problem is that scientists tend to, they can't use the type of reasoning that we use for modus ponens and modus tollens. Typically, the only thing they can do is this type of argument, which is called the fallacy of affirming the consequent. So remember, the antecedent is A, the consequent is B. So again, all A's are B's. That's a general law. And then the specific case, this C is B. This is the type of thing that scientists do. They affirm the consequent. And basically, is that evidence that A happened? So can we say this C is an A? No, we can't. This is not a valid argument. And I show you with the same method of mental models why this is not a valid argument. And because scientists need to do, the only thing they can do is this type of argument, is why deductive reasoning was criticized, and people like Bacon and others used inductive reasoning. So let's see why this is invalid. So all humans are mammals. This organism is a mammal, and conclusion, this organism is human. So I'm going to show that it's not a valid argument. We've got all humans are mammals, same as before. Now this organism is a mammal. So we can put a no there, and in this case this organism is a human as well. But we can put a no aligned with an M, and that reflects this organism is a mammal as well, and in this case it's not a human. So basically it could be a human or not. Therefore we cannot conclude that this organism is a human. Therefore this is not a valid argument.